So, hello everyone, this is Akshay here, and welcome back to the another day of our GFG period this week and the continuation of our graphs playlist. Today's question name is replace O's with X's. It's a medium character question. If you see the topic tags, it is basically the recursion, the GFS, data structures, and algorithms. Correct? So, before starting here, if you're new to this channel, please like, share, and subscribe so that you can learn, maintain, and grow our streak together. Now, let us continue with the questions. So we have been given a matrix MAT of size n cross m where every element is either O or X. So we need to replace all O with X that are surrounded by X. एक बार पढ़ लेते हैं question, then we'll understand how the input and output are working. So a O or a set of O, ये बात note करना है यार. O or a set of O is considered to be surrounded by X if there are X at locations just below, left, up and right. Right? मतलब एक ऐसा ओ, एक पर्टिकुलर ओ या फिर सेट ऑफ ओ अगर एक्स से सराउंडेड है वाया 4 डायरेक्शंस, तो हमें उन सारे ओ को एक्स में बदलना है. राइट? अगर आप ये इनपुट टेस्ट केस देखो, दो इनपुट आउटपुट दे रखा है. लेट अस अंडरस्टैंड दैट फर्स्ट, दैट हाउ इट इज एक्चुअली वर्किंग, देन वी कैन थिंक ऑफ एन एल्गोरिथम और द स्टेप्स टू कोड दिस प्रॉब्लम. ओके, तो मैं अब इन दोनों टेस्ट केस को यहाँ ले चलता हूँ अपने ओपन बोर्ड पे. एंड वेयर इज माय पेन? ओके, ठीक है. What it said, an O or a set of O. So you can clearly see if you are at this point, this is the first O you will encounter in the matrix, right? Now this is forming a set of O, correct? So this is the set of O it is forming. If we use the directions up, right, left and down. The diagonal is not allowed, otherwise this 0, 0, this two O's would have been also been included in the first group, right? So the diagonal is not allowed. Okay, so this is the first set of O, and you can clearly see that the up is the X, the left is F, the right is X, right? Down we do not need to check because that is itself an O, right? So we need to just check for rest of the boundaries. So it is in the left, it is X, for this is X, it is X, this is X. Now for this O, the up is X, the right is X, and the down is X, right? We do not need to check the left of this O because that's itself the part of the group, right? So now for this set of group, I can say that this particular island, or let's say a connected component of O, is actually surrounded by all the X's. So you need to convert this particular set into X, right? So this is the output here, and that's what is happening. These all previous O's has been converted into X. Now another set given to you as O is this one. So let me change the color. You can see this is the another set of O, or you can just say you will encounter this O, and you will see that the up is X, left is X, but in down it is out of bound. So there's a problem. That does not satisfy a constraint given the question. So that means you will just neglect this O. Right? This O will not be converted to X. So that's why this O is here. Now the next O, let's visit the next O. You can see that the up is X, the left is X, that's okay. The right and down, it is out of bounds. There are no characters present, right? अगर यहाँ पे X होता, यहाँ पे भी X होता, और यहाँ पे भी X हो जाता, तो हम कहते हैं कि this O will also be the part of the answer. But that's not the case here, so that is not satisfying the given conditions of our question. So again, this O will remain changed in output. Okay? So we have spent much time in understanding the first input case. So a little bit change in the second test case, and we will now have a very good understanding of how this problem is designed, right? So what thing we have changed here in the second test case is that you are having an extra O here, and rest of the thing is as it is, right? So let's say, so once you come at this O, you will see that your left is X, the right is X, the down is O, no problem. But for the upwards, you will see that there is no character present, that is out of bound. Again, तो ये O हमारा आंसर नहीं होगा. So if that O is not our answer, and this O is contributing in performing or in making this particular set, right? So because of this one O, इस एक O के चक्कर में, the rest of the O's which are contributing in that set will also be not part of our answer. I hope you're getting this point, because the question clearly says a O or a set of O should be surrounded by X in all directions so that it can contribute in the given answer. Okay, तो एक O ने सबके चक्कर लगा दिए भाई यहाँ पे तो कोई आंसर नहीं होगा in that case. I hope you are getting this point. ठीक है? Let us come back to this 2O, and we have this 2O is same as the present, same as we discussed in the first case. So again, this will not be the answer. So what is the output of this second test case? It is the same as given in the question. ये जो क्वेश्चन है, क्वेश्चन जो इनपुट टेस्ट केस है, वही हमारा आउटपुट भी होगा. right? Same as, I will just say input. Output is same as input, right? See, so all the dry runs which we have made, all the understanding which we have done, क्या इनमें से we can sorry, can we make out some observations? So observation number one, what we need to check, we need to be extra cautious for these elements that is lying on the border, right? Because you can clearly see that the border elements will not be an answer. अगर border element पे O present है तो वो definitely answer नहीं होगा. और उस O के चक्कर में the border element O, if it is a part of some external group, right, which itself is a set of O's, then also that particular set of O will not be an answer, right? So we need to be extra cautious for the border elements. So we need to handle the border elements which is pointing to O, correct? ठीक है. So the border elements are the first row, the first column, and the first column, and the last column and the last row, right? So these are the four things which needs to handle. That is the first column row and the last column row, correct? तो अब हम इसे कैसे मार्क करें यार? So now the second thing is कि we are at this such position, यहाँ पे border elements O है, but how can we ensure that we do not mark this set of O that is attached to the border element O, right? हम उसे mark कैसे ना करें? X, correct? What we will do here is that we will mark these extra O's with some special characters. Special characters मतलब excluding X and O, क्योंकि हमारा जो matrix है वो X और O का ही है, right? So we will mark this particular thing with, let's say, star, or you can mark this with minus or plus or any special symbol you want, right? You can even mark with this -1, right? So let us go with this one, the hyphen one for this case. तो हम क्या करेंगे, ये जो मैट्रिक्स होगा, we will run the DFS for all the border elements जहां पर भी O present है. अब अगर आपको DFS नहीं आता है, right? So I will highly encourage you guys that you please pause here and watch this video of DFS in my graph playlist. The link for this DFS video would be coming up here now, as well as you can get the description. You will get the link of the YouTube video in the description as well. ठीक है? But I will try to give you an overview कि जिनको पता है वो थोड़ा सा मेक सेंस कर पाए यहाँ पे, राइट? और जिनको नहीं पता वो डेफिनेटली देखना पड़ेगा यार. नहीं तो हो सकता है कि आपको इस वीडियो समझ में आए, बिकॉज आई विल बी वेरी ब्रीफ इन हाउ दिस DFS इज वर्किंग हियर, राइट? So we are at this coordinates, let's say X and Y. So we need to move in the 4 directions. So what is the change in coordinates it will happen? So this is the same row and we are moving one ahead in column, so it is Y plus 1, right? There is the same column, but we are moving up in the row Y. So X minus 1 comma Y. This will a row ahead in the same column, and this is the same row but the column in leftward, right? So Y minus 1, right? So we need to call this DFS in 4 directions and it will mark it. So what will happen here? So when you call the DFS for this particular O, first of all, it will mark it with minus, or let's say hyphen. Then it will go in the 4 directions. Let's say it moved left first and it will say, okay, X. So we do not want X, we just want O, right? So it moves right again, so again it's X. So it just travels back to its parent. It travels back to its parent, right? And then it go down and it sees that, okay, there is an O here, right? So what it will do, it will again mark this as minus. So let us follow the same order of left, right, the bottom and top. Let's just follow this order, or we can just go in this clockwise direction. Let's follow this: top, right, bottom and left. So now at this point of O, it will again move up. It will see. तो ये जो है, ये already visited, ये already minus hyphen से mark कर रखा है, right? So it will again trace back to its this parent call. It will go right, it will see this is X, so it will again traverse back, it will go bottom and it will see, okay, there is an O mark. So again mark it with minus, then again it will go in the all 4 directions, and only direction it will found in this here and in this here, right? So this 2 will also be marked with hyphen, right? So what is the matrix after you have covered all the border elements, right? Similarly, this will be also be marked with minus and hyphen, right? So the matrix you have now here is X hyphen X X X hyphen X X, then again X hyphen X X hyphen X X, and again you have the last row as X X hyphen. Correct. तो अगर यहाँ पे और कोई O present होता in this matrix, if let's say other O would have been present which has not been marked as hyphen, then definitely वो O भी है, वो जितने भी O बचे that is not marked with hyphen is definitely our answer. How can I say that? तो ये सेम चीज जो फर्स्ट स्टेप हमने यहाँ पर किया, दिस इज द फर्स्ट स्टेप, राइट? द फर्स्ट स्टेप हमने जो इस टेस्ट केस के लिए किया, लेट अस डू द सेम the first step for this test case as well. तो जब first step perform करेंगे, that is handling the boundary element. So you can clearly see that in the first row there is no O present, in the first column there is also no O present, and in the last column there is just this one is the last O present, right? And it will be marked with hyphen, right? And similarly the DFS will call here and it will go to its left and say there is another O, so mark this again with a hyphen, right? So I am repeating again, one who have बेसिक अंडरस्टैंडिंग ऑफ डीएफएस, देन आपको ड्राइंग समझने में कोई दिक्कत नहीं हो रही यार. अगर आपको ये समझ नहीं आ रहा कि मैं कैसे एक ओ से दूसरे ओ पे जाके एंड देन वी आर मूविंग इन फोर डायरेक्शंस एंड मार्किंग विद हाइफन, देन डेफिनेटली यार आपकी डीएफएस की अंडरस्टैंडिंग थोड़ी सी वीक है, थोड़ी सी, एंड यू नीड टू जस्ट कवर दिस वीडियो दैट आई हैव मेड इन द ग्राफ प्लेस एंड यू विल बी गुड टू गो, राइट? सो once we have visited, so coming back again in the first case, once we have visited this O for the first time, it will mark this as hyphen, it will mark this as hyphen, right? So what is the resultant matrix after the first step that we have performed? It will look like this. So X, 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 the second row is X, the O, X and X, the third row would be X, double O X, and the fourth row would be X, O, X, X, and the last row would be as X, X, hyphen, hyphen, right? So we have covered, or we have done the DFS for all the border elements, and this is what we have obtained after doing that particular DFS, right? So can you say now that whatever O is now present in this matrix after doing the first step, that is your answer, right? Because हमने क्या दिखा था यार कि border elements ही परेशानी कर रही है. The border elements, we are forming a group with the another set of O which is present inside the matrix, and that is not contributing in making it to X, right? So first we handle the border elements, and after doing that, whatever O we have in the matrix left, you can clearly see that these O's are already surrounded by X. अगर ऐसा नहीं हुआ होता, let's say, then this would have already marked with hyphen while we were doing the DFS for all the border elements. Correct? Correct. Okay. So the second step. So this is the first step. So let me just scroll it down now. The second step, right? So traverse in matrix. Traverse in matrix and mark O with X, right? So once you are done with this second step, what would be your resultant matrix? That this O, this everything has been changed into X, right? But you need a third step as well, because the some things you have changed the O in the hyphen, right? And these to be converted hyphen back to O, right? Because these were that O's which cannot be converted to X. So the third step would be the traverse in matrix again and mark the hyphen with O. Correct? So that's it for this question here. अगर आप यहाँ तक बने रहे थे, if you're able to understand each and every step which I have explained you in this particular question, then definitely I can guarantee you, I hope that you don't have any doubts or whatsoever for this particular question, right? And अगर आपको doubts आ रहे हैं, then I'm pretty sure that you must not been able to follow me where I tried to explain you the DFS part, right? So much watch this video if you're not able to, and then come back to this video again, and I hope you will get a good understanding, right? Okay. So what next? What would be the pseudocode now? So what would be the pseudocode? तो हमें यहाँ पे दो for loop की जरूरत पड़ेगी यार. First of all, a for loop for here and for loop for here to traverse in the first row and first column and the last row and last column, right? And for each and every cell, which is for each and every boundary cell which has the character value as O, we need to do a DFS. So in the DFS, let me write a pseudocode for DFS now. So what would be the parameters involved in the DFS? So first of all, you need to pass your matrix. Then we need to pass your coordinates, right? And then you need to pass the previous character and the new character, right? So previous character would be nothing but O here in this case, and the new character would be nothing but the hyphen in this case. And you need to pass N and M, that is the matrix length and matrix size, basically, right? What do you need to check now? What would be the base case for the standard DFS? whatever the indexes that you are passing, that should not go out of bound. So the first base case would be to check for out of bound. How you can write it? I can write it as like this: if x is less than 0, right, or x is greater than equals to n, right, or y is greater than 0, or y is greater than equals to m, right? So these are all the coordinates which will be saying out of bounds, correct? This is a very basic thing here. अब उसके बाद हमें क्या करना है कि the if you are traversing to the, you need to traverse for rest of the 4 neighbors, right? So you need to call the recursive call for 4 neighbors. So what you will do, you will call the same thing, the DFS, the character array, the x. So what are now, this thing will come in handy, what we discussed when you try to traverse in the 4th direction, what is the change in coordinates. So we will do x comma y plus 1, then we will do x plus 1 comma y, then you will do x comma y minus 1, then you will do x minus 1 comma y. Now these 4 things you can write in any directions. I have just started from this, and then I moved the clockwise direction to cover all the coordinates, correct? Now you pass rest of the parameters, a, you call the DFS, you call the DFS again, you call the DFS for this last call as well. And what are the other parameters? Is the again the previous C, the new C, and the N and M. And the same goes for these 3 calls as well, correct? So I'm just writing it like this, and that's it. And what you need to do, one more thing here, is that the neighbor which you are visited, so you will see that the neighbor which I am be visiting, if it is not equals to my previous character, right? Previous character in the sense, suppose I'm at this O, and the neighbor which I'm visiting, if it is not equals to O, then we do not need to change it, right? So if that's the case, then you do not need to change it and you need to stop the recursion. So I will say return. Now, if that's not the case, if the neighbor you're visiting is equals to O, you need to mark it with hyphen, right? So I will say A of x and y is equal to hyphen. Done. And I will do for all the 4 neighbors. That's it. Yes. So that was the maybe say thoda sa difficult part while coding it if you have not good understanding of DFS. So I explained you all the things now with the logic, with the pseudocode. Now it's your time to pause this video here and try to code all the 3 steps. That is this is the first step, that's the second step, and the third step in your code editor using this helper function as DFS. And one more additional information, that the thing which you're doing here is, this is also known as the algorithm as flood fill algorithm. Now I will not explain you this flood fill algorithm in detail, but since you have understood the DFS code, then definitely you can go ahead and do a Google search on flood fill algorithm, and you will definitely get a good, like, बहुत easy हो जाएगा आपको समझने में, right? Now it's already 17 minutes, and let us now proceed to the coding section. And meanwhile, you also try to code it, and I'll finish the coding and then I'll resume back. Okay, guys. So now it's the time for our moment. It's time for the code, not the moment. Okay, so that's the first for loop, which is handling for the first column and the last column. We are using the I equals to 0 to I less than n, that is iterate in the rows. So what I'm saying is that I start to iterate in the rows, right? So I'm using the pointer to go in this size, right? And we need to call the DFS for just this one and this one. So here its I is equals to 0, and at the last its I is equals to m minus 1, right? For all the elements present here. Correct? So here all the elements would have the, what say? Okay, so basically it's the first column. So the first column will have that we need to traverse in each row, but the column index has only 0. So that's what's happening here. The column index is only 0. Now we are using the i8 pointer to traverse in each row, but we are only doing it for m minus 1, right? Correct. Okay. The same thing which we are doing now. I don't think explanation is required again for this thing. For the another for loop, I don't think explanation is required. So again, so that's we are handling the first row and the last column. Again, you can have just use some print statements to just debug that what actually we are getting after the first step is done, right? Okay, you can also just do this thing and can verify with the drawing we just made. So I'm not doing that again, doing the efficient time management here. So again, so the second step was to change the existing O to X, because that after doing the DFS calls, if some another O or a set of O is present, then definitely that O is a part of our answer, and then we are changing that existing O to X. At the last, whatever the DFS call we have made and change the previous O's, to hyphen, we need to change back to X so that we can return the final answer. So that's what we have done. And at the last, we have just returned A. So A is nothing but the matrix given as the parameter input. So we have make some changes in that matrix as well. We have make changes in that matrix and we have returned that matrix as output. ठीक है, ये वीडियो बहुत लंबी हो रही है. Okay, so there is an helper function static void DFS. Again, I've explained you each and every step here. So again, I will skip the code walkthrough for this thing and I will just hit the compile and run. While this compiling and running, so what is the time and space complexity? So we are visiting each and every cell and we are calling DFS for all the set of O if exists, right? So that means we are visiting each and every cell and marking it, right, with O. And if that's not the case, if it is already marked with O, if the existing was already marked with hyphen, we are not visiting back to again, right? So that means traversing each and every cell will give you O of n cross m, correct? And that's the standard DFS time complexity takes as well, right? And what is the space complexity? Again, what is the space complexity? So we are not using any another data structure to because we जो input में हमारे पास A था हमने उसी में changes उसको return करा, right? But there is an additional space complexity that is involved with the DFS, that is a recursive stack space, right? So okay. So again, what is the space complexity involved in DFS? Again, it's V plus E. That is all the available nodes present in the graph. So here, all the available nodes is n cross m. So it will be space complexity again O of n cross m. Let me give a very high overview for how that is the n cross m. So let's say for this there is a cell here which is marked as O, and you traverse in right hand side, right? Now again there is O, you again traverse, and let us assume that all the matrix was filled with this O, and you keep on traversing the O, right? So all the traversal that we are making will be stored in a recursive stack. That is for this index, let's say this is index 1. Then you move to another node O, it will be, let's say, index 2. Another O is there, it will be index 3. And let us assume that everything is marked with the O. And in that case, you will be visiting each and every cell, marking every O with hyphen, right? And that is why, and that's how I'm saying that the worst case would be for the space complexity would be n cross m. So that is it. Let us hit the submit button now as the compilation has run successfully. Okay, the solution has been successfully submitted now. Let us switch back to the C++ code again. Okay, so that's the C++ code. I don't think a code walkthrough is required. The same things that we have done in Java and the run. So let me just scroll it through for you to take help. And do not worry, I will mention all the source code. It will be available in my DSA repository, so you can start and fork the DSA repository to get help with the source code. And yes, let us meet again in the continuation of this graph playlist and in tomorrow's GFG POTD streak of 312. So yep. So till then, keep learning, keep growing. Bye bye, and take care, guys.